Moving on to example 3, where again we're going to be solving a nonlinear system algebraically. So when we do this, we know that y is equal to 3x, and also y is equal to x cubed minus 6x. So it really doesn't matter which one we choose here. Let's choose the first one to put into the second equation. So x cubed minus 6x will equal 3x. Getting everything to one side, we'll end up getting x cubed minus 9x is equal to 0. You should be able to see that you can take an x out, be left with x squared minus 9 is equal to 0. From your algebraic background, you should see that x and the x squared minus 9 will factor to x plus 3x minus 3. So our options for x will equal 0, 3, and negative 3. When you put that into either of the two equations, x equals 0, 3, and negative 3, you'll get y is equal to 0 when x is 0, 9 when x is positive 3, and negative 9 when x is negative 3. So our options for our answer is 0, 0, 3, 9, and negative 3, negative 9. If you can factor, factor. If you can't, you have to complete the square or use the quadratic formula if it's a quadratic equation. This is not. Moving on to example B, we see that y is equal to 6x squared. So I can put that into the bottom equation there. 7x plus 6x squared is equal to 3. Moving this around a little bit, we get 6x squared plus 7x minus 3 is equal to 0. Believe it or not, this is factorable. 6 times negative 3 is a negative 18. So are there two factors of negative 18 that give you 7? Well, yeah. Positive 9, negative 2. The thing is, we need to figure out what we need here. Well, my only factors of 3 are 3 and 1. So we can put those like that. Now we got to figure out signs. Well, I need a positive 9 and a negative 2. Well, the only way I'm going to get that, to get positive 9, will be a 3 here and a negative 2 here. So we can put, that's going to be the negative 1. And then we'll have a positive 2x here, a positive 3 here. So factoring it down, that's what you get. So x here will equal 1/3 or a negative 3/2, solving those for x. Putting those in for the original equation there, y will equal 6 times 1/3 squared, which means y will equal 6 times 1/9, which is actually 6/9, which is 2/3. Also, y will equal 6 times a negative 3/2 squared. Negative 3/2 squared is 9/4. Well, 6 times 9 is 54, divided by 4, or we can go like this. This will be a 3, this will be a 2. 27 over 2, which is 13.5. So our answers could be 1/3, 2/3, or negative 3/2 and 13.5, or 27/2. So there you have it, for example, 3B. Now, when we talk about solving systems graphically, sometimes the method of substitution leads to an equation in one variable that we're not able to solve using standard algebraic techniques we studied in this text. In these cases, we can only solve the system graphically by finding intersections as illustrated in example 1. Now, if you remember right, I actually did this for example 2A as well, just to show you what those are. Now, consider the system. Y equals ln of x and x squared, y equals x squared minus 4x plus 2. So in the first equation, ln of x. In the second equation, we'll have x squared minus 4x plus 2. Now it says draw the graphs of the two equations in 0 to 10 and negative 5 to 5. So our window 0 to 10, x scale will be 1. Negative 5 to 5, our x scale will also be 1 again. So when you graph these, that's what you're going to get. ln of x will be the one that's going slowly as x approaches infinity. X squared minus 4x plus 2 will be as the second graph going to infinity a little quicker. Now use the graph in part 1 to find the coordinates of the points of intersection shown in the viewing window. Well, you press second trace, go down that intersection. We're going to go left here. So I want to find the intersection closest to the origin there first. So our first intersection will be about 0.711 or 0.71. And also negative 0.34. My second intersection, we found much the same way. Press second trace, get close to the intersection point, 3.83 and 1.34. Those are your two intersection points. Now, it says, number 3 says, use your knowledge about the graphs of logarithmic and quadratic functions to explain why this system has exactly two solutions. Well, because you know it's quadratic, that means it's going to look like a parabola, as shown. Now, natural log only exists in the first and fourth quadrants, the positive x-axis. So, because we chose our window 0 to 10, we know there's not going to be any version of the ln of x left of the x-axis or for negative x values. So therefore, we know it's only going to have these two solutions. So that's how we know about the graphs of logarithmic and quadratic functions. Nothing's going to be left of the x-axis or left of the y-axis for negative x. So that's why those two intersection points we found are the only two that we have. Now, if we substituted ln of x in for y in the first equation, put that in the second equation, we get ln of x equals x squared minus 4x plus 2. Now, there are no standard algebraic techniques to solve this equation, so that's why we had to do it graphically. Now, we're going to move on to the method of elimination. Now, consider a system of two linear equations in x and y. To solve by elimination, we rewrite the two equations as two equivalent equations so that one of the variables has opposite coefficients. Then we're going to add the two equations to eliminate that variable. You've done this before, so it shouldn't be anything new to you. Now, in example 4a, we need to eliminate either x or y. Because the x's already have opposite signs, we can easily multiply the top equation by 3, the bottom equation by 2, to get positive 6x and negative 6x. So when we do that, we'll have 6x plus 9y equals 15, negative 6x plus 10y equals 42. When you add down, we'll have 19y is equal to 57 because the x's go away. Dividing by 19, y will equal 3. Now, once we get y is equal to 3, we can put it into any of the two equations that we have. Let's choose the top one. 2x plus 3 times 3 equals 5. 2x plus 9 equals 5. 2x equals negative 4. X will equal negative 2. So your answer here will be negative 2, 3. Now to check, 2 times negative 2 is negative 4, plus 9 does equal 5. Negative 2 times negative 3 is positive 6. plus 5 times 3, which is 15, so 6 plus 15 does equal 21. The answer does check. Moving on to B, because our y values have opposite signs, we can multiply here, multiply the top by 2, the bottom equation by 1. So we'll end up with 4x plus 2y equals 20, and x minus 2y equals negative 5. Therefore, in this case, our y values will cancel out. We'll have 5x is equal to 15 when you add down, which means x is equal to 3. Putting these in any of the two equations, let's put it in the bottom one, let's say. Actually, let's put it in the top one so we don't have to divide with the y. 2 times 3 plus y equals 10. 6 plus y equals 10, which means y will equal 4. Now, had we put it in the bottom one, we get 3 minus 2y equals negative 5. Negative 2y will equal negative 8, which means y equals 4. It doesn't matter what one you choose, you'll still get the same answer, which means our answer will be 3, 4.